So good day everyone. So before I will be going to discuss about my topic, let me introduce myself first. My name is Sanray Cordon Deralon. I'm 20 years old. I live in Lacunan, Tiboli, South Cotabato and currently studying at Sultan Kudarat State University, Isulan Campus with a Bachelor of Science in Civil Engineering. So the first problem that I will going to discuss is about implicit differentiation. So when we say implicit differentiation, it can help us to find dy over dx or even our relationship like that and differentiating each term separately. So the first problem is so the first problem is x squared minus xy plus y squared is equal to e to the power of negative x, then find dy over dx. So the first thing or the first process that I will going to apply is about power rule, because as we can see there is a variable here, there is x squared, because the derivative of x squared is reflect to x. So let's simplify first because it is an easiest way to get the answer directly. So let's apply the power rule. So the first step is we put 2 here, 2x minus x. Because in exponent, we should always subtract it to 1. So that's why 2 minus 1 is 1 or written as x or minus x. Then, the derivative of d over dx so this is now 2x minus x to the derivative over dx, quantity of y, minus y plus 2y d over dx, the quantity of y is equal to negative e to the power of negative x. So after that, we have to evaluate this part of process. So So this is negative x d over dx, the quantity of y, plus 2y to the derivative over dx, quantity of y, is equal to e to the power of negative x minus 2x plus y. So after this, we have to evaluate this part of process. So as we can see, the derivative is in the middle of the variable, which is the x and y. So we have to evaluate it. So as we can see, we have to, after this process, so we have to determine where is the similarity. So we have this part of process, so we have to cancel out what is the similar between the numerator and denominator. So as we can see, there is similar. So we have to cancel this negative x plus 2y. So After that, we finally get the value of dy over dx. So the final answer for problem number 1, as we can see the problem is to find the dy over dx. So dy over dx is equal to negative e to the power of negative x to the power of negative x minus 2x plus y all over the quantity of negative x plus 2y. So this is the final answer for problem number 1, and this process I will use a product rule because product rule is for implicit differentiation for us to get an easiest way and then to apply directly. So in problem number 2 is all about the number higher order derivatives. So when we say number higher order derivatives, it is the process of differentiation can be applied several times in succession, leading in particular to the second derivative. So in problem number 2, sine x squared y is equal to g since g is equal to 9.8. So with this equation, the first thing is to write or indicate the derivative into the given problem, and it should be written as so we have the derivatives of d over dx, the quantity of sine, quantity of x squared y is equal to the derivatives of d over dx to the quantity of 9.8, which is 10.8 is the value of g. So the next is cosine the quantity of x squared y to the quantity of x squared to the derivatives of d over dx, quantity of y plus y to the derivatives of d over dx to the quantity of x squared is equal to 0. So as we can see, I put cosine here since the given problem is sine, because in trigonometry rule, the derivative of sine is equal to the cosine. So that's why I put cosine here. So after this process, so we have to evaluate. So cosine the quantity of x squared y, quantity of x squared y prime plus 2yx is equal to 0. So as we can see, there is a y prime here because if we derive a function or variable, there is always a prime. So as we can see, after this, we have to apply the chain rule. So as you can see, we have to substitute the cosine into the quantity, the value of inside the quantity. So x squared cosine, the quantity of x squared y plus y prime plus 2xy cosine to the quantity of x squared y. So this is the process that we are going to apply the chain rule. So this is now the process of part of the process, which is we'll be using chain rule. So 2xy cosine to the quantity of x squared y plus x squared cosine the quantity of x squared y plus 2xy cosine to the quantity of x squared y is equal to 0 plus 2xy cosine the quantity of x squared plus y. So after this, we should observe, or we should determine where is the similarities, and we have to cancel. Where is the part of this have the same, and we have to cancel it. So as we can see, there is similar, and we have to cancel this one. 2xy cosine x squared y. This is cancelled, and this one. So after the cancellation, so we have to write what is inside of this, what is in the left value, and what is in the right. So as we can see in left part of the process, so we have x squared cosine to the quantity of x squared y, y prime, all over. We have to copy this, and we have to put it in the denominator. X squared cosine, quantity of x squared y. Same way in the right side. We have 2xy cosine, the quantity of x squared y, all over. We have to copy this. X squared cosine, the quantity of x squared y. Then after that, we have to cancel again what is the similarities between the numerator and denominator. So this one, we have cancelled this one. And after cancellation, we can definitely find the value of y prime. So as we observe, y prime is equal to 2xy cosine, the quantity of x squared y, all over x squared cosine to the quantity of x squared y. So as we can see, for us to be able to reach the value of y prime exactly, so we have to cancel again what is the similarities between the numerator and denominator. So cancel this one, cosine the quantity of x squared y is cancelled. So the value of y prime is equal to 2y all over x, because 2xy all over x squared. So there is variable here in numerator x and then the denominator x squared. So cancelled x in numerator and cancelled 1x in denominator. So that is why the numerator is 2y, because there is no x in numerator, and all over x because 1x of the denominator will be cancelled. So that is why the value of y prime is equal to 2y over x. So since number higher order derivatives is, we can find the second derivative. So here is the continuous process. So the derivatives of d over dx is equal to 2y over x. So 2y over x is the value of y prime. So the derivatives of d over dx is equal to 2y, then the quantity of x to the power of negative 1. So d squared y all over dx squared is equal to 2y, the quantity of x, minus or to the power of negative 2. So it should be negative 2 because negative 1 minus 1, it should be negative 2. So after, it should be 2yx raised to negative 2 because we have to substitute the 2y inside the quantity, which is the x to the power of negative 2. So that is why 2yx raised to negative 2. So after this, so we can definitely find the value of the second derivative. So d squared y all over dx squared is equal to 2y over x squared. So as we can see, or as we observe, here are the parts of the process, 2yx to the power of negative 2. So 2y, it should be put in numerator, and the x to the power of negative 2, it should be put in or indicating in the denominator, because as we can see, there is negative, because in rule of product rule, as we use product rule in number 2, there is no negative answer in product rule. So that is why we have to put, or we have to indicate the x to the power of negative 2 into denominator for us to be positive. So that is why the value of d squared y all over dx squared is equal to 2y over x squared. So I hope my topic today, my discussion is well good, and I hope everyone should have a knowledge about what I'm going to report, what I'm going to discuss about implicit differentiation and number higher order derivatives. So that's all, and thank you.